Hi everyone, my name is Stephanie Kingham and this is my Kamiak Butte term report. Throughout this video, we will be learning about Kamiak Butte from the very beginning all the way up to now. Some of the things we will be exploring are its climate, comparing the north and south aspect, the air masses that have an effect on Kamiak Butte, and much more. There are many different species that live there, with about 166 different bird species and 170 different kinds of vegetation. With all of its trails, many people go to enjoy the views. Now let's learn more about Kamiak Butte. Earth used to be filled with supercontinents, which were eventually broken up by plate tectonics. The theory that lithosphere is divided into several plates. When these plates move, they create features such as volcanoes and oceans. The lithosphere has two plates, oceanic and continental. The oceanic plate is a lot denser than the continental one, so it subducts under the continental plate when it moves. This pushes volatile material that is eventually released as magma. When Pullman was right by the coast, all the sand near it was being crushed and eventually turned into quartzite rock. As the plates moved and volcanoes erupted, more and more land was created, separating Kamiak Butte from the ocean. Magma rises from cracks in the earth called fissures, covering more of the landscape in magma. The magma seeps out and covers the ground, drying into hard rock. More magma eventually seeps out and creates these layers that are familiar with basalt. The Yellowstone hotspot is the cause of these volcanoes that are now called the Rocky Mountains. The map shows just how big the basalts are. The basalts did not occur quickly, starting about 17 million years ago, with the waning phase occurring 15.6 to 6 million years ago. Feeder dikes and deep river canyons are created as well as interesting rock formations due to the spattering of magma. After the flood basalts were formed, glacial flooding occurred during periods of ice age. As the earth began to warm, massive lakes formed. Glacial Lake Missoula formed because of an ice dam in northern Idaho. This dam was nearly 2,000 feet tall and 30 miles long, sealing off a mountain valley. The pressure increased to a point that the ice dam failed and the massive lake drained. High-speed water sped over the landscape over the course of a couple of days. The water made deep cuts into the rock and moved huge rocks from the Rocky Mountains. The flooding occurred more than once, affecting the landscape each time. As the winds picked up, low soils, a very fertile soil, was blown onto the basalt lands. These low soils is what makes the Palouse such a fertile farming ground today. The climate of Kamiak Butte is something of interest. It seems like it should have different kinds of climate because of how the north and south aspects look, but it in fact has generally reoccurring climate. Air masses are huge bodies of air that have a certain type of temperature and moisture content based on where it was formed. These bodies of air have a huge impact on temperature and precipitation. The type of air mass that should have the greatest effect on Kamiak Butte is a marine polar air mass. These air masses are originally from Asia and are then modified by the ocean as it travels to the United States. The mountainous areas protect the butte. Sometimes, a strong wind may send it over, but the temperature usually never gets too high or too low. The average high is around 56 to 59 degrees Fahrenheit, while the average low is around 25 to 28 degrees Fahrenheit. Continentality is a factor in terms of the climate of the area. Continentality is how far an area is from the ocean and is graded on a scale from 1 to 10. Kamiak Butte is about a 4 on the continentality scale. As shown by the map, areas closer to the ocean will generally be cooler and have a moist air quality. Kamiak Butte gets about 16 to 20 inches of annual precipitation. Topography is the arrangement of physical features of a piece of land. The greatest influence on topography are mountains. Topography has an impact on rain shadow. As the air masses from the ocean travels across Washington, the air cools and the rain starts to fall. Mountains cause orographic lift and the air is pushed to the top of the mountain. This cools the air even more as it rises, causing more rain. The air mass goes down the east side of the mountain and warms, making it hold in more moisture and stalling precipitation. Rain shadow allows plants to thrive on the western side of the mountains in Kamiak Butte, while the eastern side cannot hold as much life because there is a decrease in precipitation. Macroclimates are a result from origin of air masses, latitude, continentality, and topography. They are also affected by high and low pressures. Low pressure causes warm air, high winds, and atmospheric lifting. Rain is common. With high air pressure, clear skies and nice weather are a common occurrence. They can, however, experience temperature extremes. Kamiak Butte is affected by the subpolar low-pressure cell, which is caused when cold air from higher latitudes and warm air from lower latitudes combine. Kamiak Butte experiences a wet winter and a dry summer. Plant life and wildlife that are affected by a certain type of climate is called a biome. Examples of different biomes are warm desert and central hardwood forests. Factors like precipitation, soil, and amount of light are a big indicator on what kind of biome an area is. Biomes can also have transition zones where one type of biome ends and another begins. Kamiak Butte is a North America western interior shrublands and woodlands biome. There is a mix of shrubland and oak trees. As a reminder, the type of soil on Kamiak Butte is called low soils. The Missoula floods eroded some of the soil and left some areas of basalt exposed. These areas do not provide fertile land for crops. The transitional zones include that of the traditional prairie and the woodland area within Kamiak Butte. Now let's see what we observed during our field report. Here is what we observed about the north-facing aspect of Kamiak Butte. Here, there are a lot of trees present with a couple of shrub and grass species thrown in as well. In the areas that we sampled, there was 156 ponderosa pine, 156 Douglas fir, and 156 western larch per acre. The understory species included mallow ninebark, snowberry, and woods rose. For the south-facing aspect, the area looked to be more barren. There are less large trees and more grasses. The understory species included fescue, annual grasses, serviceberry, snowberry, and wheatgrass. These types of plants are more adapted to drier conditions and to the intense solar radiation hitting them. The soil is a lot drier here because of less precipitation due to the rain shadow effect. An interesting part of Kamiak Butte are the lichen that live within it. Lichen contains two different organisms, fungi and algae. Lichens are very diverse, with thousands of different kinds. Lichens have a plant body called the thallus, with the most well-known types of thalli being crustose, foliose, and fruticose. Crustose are able to withstand dry conditions and look almost like a crust on the surface. Foliose are more leafy that thrive in areas that have high precipitation. Fruticose have stalked thalli and they prefer to live in an area with high humidity. The attachment of lichens onto areas that they should not be able to hang on to is what makes lichen be able to thrive in many harsh places. There are a couple of attachment mechanisms that lichen use. Rhizines are filaments that are part of the fungi that come from the medulla, which are fungal cells located in the middle of the lichen's thallus. Rhizines' only role is to hold lichen onto the substrate. Lichens can also have a holdfast, which is a part of the thallus as well. Now, onto the reproduction of lichen. Reproduction for lichen is interesting because there are two organisms at play here. The types of lichen that reproduce sexually are ascomycetes or basidiomycetes. Both use spores to reproduce. The spores can reproduce for the fungus, but the algae do not leave the lichen. The new fungus has to find new algae to attach to in order to become lichen. Asexual reproduction can occur when part of the lichen breaks off from the thallus and attaches to another substrate. The two organisms within lichen are in a mutualistic relationship. These two organisms come together to accomplish what one could not do by itself. Fungi cannot photosynthesize, and algae cannot hold on to certain substrates. When both are together, both of these organisms help with accomplishing both tasks. There are about 5 different types of lichen on Kamiak Butte. Fremont's horsehair is a fruticose lichen. It is dark brown and looks like hair. It prefers to grow on conifer trees and in areas that are very sunny. This lichen would most likely grow on the south side facing slope because that side of the mountain does not get as much rain. The next type of lichen is the Lapland beard lichen. This one is also a fruticose lichen. This lichen has droopy features. This lichen grows on sick or dying trees because there's more light hitting the bark when there's no leaves to shade from the sun. This lichen can also be used as a bioindicator. Wolf lichen is our third kind. It resembles neon green moss and lives on many types of trees. Animals do not eat this lichen due to its poisonous properties. The fourth lichen is shield lichen. This is a foliose lichen. New growths are around the perimeter and are slightly raised. It has a light ashy green color. The last lichen is called lung lichen. This one is also a foliose lichen. They are big with leaf-like structures. They are also bright green in color with a paler green underneath. Thank you for listening to my presentation on Kamiak Butte. Kamiak Butte has an interesting ecosystem with many types of diverse species. A trip to Kamiak Butte is a major learning experience that benefits all.